So let's do a little bit of a deeper dive into this code and what's actually happening here. So first, of course, we have our imports. This is just like any other Python library. And so what we're doing here is we're first initializing our application. So we're saying app equals application hello world. And you can see here that our name is the first argument and it's the only required argument. If we wanted to provide additional information like a description or specific build options, we could also do that here. But in this case, we're just initializing a basic Beaker application called hello world. And that's where this comes from. As you can see, this is coming from Beaker. So we initialized our app now, and now we want to add some methods to it. So what we have to do is write our Python methods and then add a decorator to them to tell our Beaker application to include the method in our contract. So for example, if we just had def hello without our decorator, Beaker wouldn't know that this should be included in our application. What this app external does is it tells Beaker when we compile our contract to include this method in our smart contract. Also, as we come to our contract JSON, we can now see, so in our source code, we have hello, the name is a string, and our output is a string, and we'll be going over this syntax in just a second. And we can see we have our argument name, which is a string, and it returns a string. And so that's what this at app.external is doing. It's saying this is an external method that I want to be publicly callable and exposed through our ABI. So add this to our Beaker application and put it in our ABI contract.json file. So now let's go over the method signature itself. So the first part here is regular Python. We're creating a method called hello. So in our ABI, be called hello, pretty straightforward. And then we're providing an argument and it's going to be an ABI.string. Now, the reason why we have to do ABI.string, not just string, like the Python class, I can't remember if it's uppercase or lowercase, but the reason why we're doing ABI.string explicitly is because if we just specify a Python string, Algorand doesn't know what to do with that. Algorand at the end of the day runs teal, and teal only has two native types: byte slices, which are like raw binary data, which we use to represent things like strings, or integers, so unsigned 64-bit integers. So in order to tell the AVM that we're working with a string, we need to use the application binary interface to tell Beaker convert our string into a native byte slice. And so what this basically means is that we are going to be passing in some data and Beaker will automatically encode it and decode it to a string in accordance with the ABI standard for us. So anytime you're working with a type in your method, it's always going to be an ABI dot type. So that's our input. Again, very similar to a standard Python method. We have an argument name and its type is going to be ABI string. And again, if we go back, we can see here that we have our name and type is string. Now let's go over the next thing that we have in our signature here that might be a little bit foreign to you, especially if you're not a Python developer. What the star is doing is separating the arguments from the arguments with a specific name or keyword arguments. So here before the star, these arguments that we pass in can be any name. We can name them whatever we want. But then after the star, we have special keyword arguments. And when we're writing a Beaker method, we only have one keyword argument, and it must be called output if we want the method to return a value. Here in our case, if we go down here, take a peek at delete, there is no output because we're not returning a value, so we don't need to find it here. But here in this case, we want this hello method to return a string. It returns hello Beaker in our case. And so we want to specify the type of that return. Now you might be asking, why is this return type here not string? And why are we defining the output here rather than here? And this is where we get into PyTeal itself. So what PyTeal is, it's a library for writing what we call expressions that translate into on-chain logic. So every single method you use in Beaker must ultimately return a PyTeal expression because that's what the PyTeal compiler, knows what to do with. If we just returned a Python value, for example, that wasn't a PyTeal expression, the PyTeal compiler wouldn't know what to do with it. So again, out our return value or output for our on-chain logic is actually contained in this output variable here. So now if we go down and look at our source code in our method, what we're doing is we're returning the value returned by output.set. And if we take a look, this returns an expression. So what output.set is doing, it's basically saying, take our output variable. So we have some container that's going to hold our output value, and we want to put a new value in that. And we're going to say output.set, and we're going to call this concat method. And what this concat method does is it takes two strings and then just squishes them together. And so we're going to take our hello string and then call name.get to get the name that we passed in. So here, all we're doing is basically saying, get our container holding the output and put in the value of hello concatenated with our name. As you can see here, that's exactly what's returned here when we passed in Beaker. Now, one other thing to mention that's really important is this bytes hello. Again, in PyTeal, you're working with expressions, not with native Python types. So when we want to work with a string, for example, we can't just type hello. Or to go ahead and try to run this, let me go over to build and deploy, and I try to run it. It's going to it's going to say argument is not a PyTeal expression. And that's because the PyTeal compiler doesn't know what to do with a Python string. It only knows bytes class. And this is the same for integers, which I'll show you in a little bit. Now, one other thing to note before we get started writing our own code is this delete function. So on Algorand, you have the ability to delete and update contracts, but with Beaker, you have to explicitly define what method will be called in order to do those sort of operations. So if we take a look here, we're going to skip this decorator for a second. And in our delete method, we have no arguments and it simply returns an expression. And the only expression we're returning is approve. So off first glance, what this looks like is that whenever someone calls the delete function, it will always just pass. And because it's return approve. The exception to that is that we have this decorator. And in this decorator, it's similar to external. So what this is basically doing is it's telling Beaker to add this delete function to our application. But we have two additional options here. So the first of which is called bear. What this is basically saying is if we try to delete the application, we don't actually need to specify what the method name is. And so this touches on an important concept for Algorand Smart Contracts called the onComplete value. So on Algorand, we have what's called an onComplete, and this specifies what the contract does at the end of the program. And so in our case, update is a non-complete. We also have a delete, and there's here state, goes out as well. And then we also have no op. And each of these do different things. And some of them are pretty self-explanatory. Delete will delete the application, update will allow you to update it. So basically what we're doing here is saying the onComplete for this delete method has to be delete. So whenever we call a contract telling the chain to delete it on completion, Baker knows to route to this method because we provided the at delete decorator. And then what this bear does means when we call this, we want to call this method, we don't actually have to specify the method name. If we simply call this contract and try to delete it, it'll automatically route us to this logic here. And one thing worth mentioning, this at app.external, it's mapping to this no op, which basically means don't do anything special. That is our bear decorator. What it does is allow the program to delete without specifying a method specifically. Then we also have this very important authorized keyword argument. What this is basically saying is do not allow this method to execute unless this condition is met. In our case, we're using this authorized dot only global creator address. So what this basically means is that we are only going to be authorizing the person that created this contract to call it. So if someone tried to call this contract, tried to delete it, and they were not the creator, then what will happen is the contract will then reject the transaction and they won't be able to delete it. So this authorize is what protects anyone from being able to come and just delete this application. So that covers our on completes and our delete decorator. There's also one more opt-in. Again, we're not going to be going over all these, just posting it here. That covers kind of our first initial overview of what this contract is doing.